Hello everyone, welcome to my chemistry channel B.Ldash, short and sweet in chemistry. Now the topic is short revision in electrochemistry. Now I am going to explain the product of electrolysis in short revision of electrochemistry, where it is part 16A and class 12th. Now you will see what is electrolysis in the part 15. Now we will see what is here the products of electrolysis. So many electrolytes are there. Then electrolytes when dissolved in water or in molten state, they give some product. Then what are the products in a electrolysis? This electrolysis generally we know it gives cation and anions. Now we are going to see what are the products. Here the product depends on the nature of material which is going to electrolyte, just like sodium, chloride, water, sulfuric acid, all the types of electrodes being used. And the different type of electrodes used and different types of electrolytes are used, and all that product depends on the nature and electrodes, nature of electrolyte and electrodes, type of electrodes. If the electrode is inert, so what is the meaning here? Electrode may be also inert. Inert means it is not active. That means example platinum or gold. PT means platinum, AU means Rm means gold. It does not participate in the chemical reaction and also act only source and sink of electron. So it is never undergoing in the reaction of the electrolysis, and here only at the source of electrons giving or taking, source or sink for electrons. So that means first point we see the nature of material for electrolytes and type of electrodes, then the inert types of electrode. Then what are the types of electrode? One is inert example platinum and gold. Then next is your third point, if the electrode is reactive. If the electrode just like copper, just like zinc, if these electrodes are reactive, then what happens? It participates in the electrode reaction. Then if this electrode is reactive and participate in chemical reaction, then what happens? Here the products are formed, and the products are different for reactive and inert electrode. Now you remember when the electrolysis takes place by the help of inert electrode and by the help of very active electrode, the products also different. The products of electrolysis depend on the different oxidizing and reducing species present in electrolytic cell. When electrolysis is proceeding, and here reducing species and oxidizing species also are there in electrolytic cell, and their electrode potential also standard electrode potential you should know, just like Cu plus 2, Zn plus 2, Zn, Cu, and here you see what is their standard electrode potential and what are the oxidizing and reducing species in an electrochemical reaction, and that electrolysis when takes place. Some electrochemical process through feasible are so slow kinetically. That means some chemical reaction, although it is feasible, but very slow one. At very slow one means lower voltage not seem to takes place. That means here low voltage is produced, and here extra potential called that is over potential has to be applied, which makes such process more difficult to occur. That means extra potential means over potential that to be applied, which makes such process more difficult to occur. Here what you understand, that means here some chemical reaction takes place when electrode is very active And then here, though feasible reaction but very slow kinetically, at low voltage not seem to take place, low voltage is produced, and here extra potential called overpotential that be applied, which makes such process very more difficult to occur. First example, electrolysis of sodium chloride. Because sodium chloride is such a compound, ionic compound, easily it is ionizable by the passing of electricity. It is also very applicable. That means here NaCl is ionized. So NaCl, when it will ionize, two conditions. One is when molten sodium chloride, another is electrolysis of sodium chloride, breaking of sodium chloride ions. So molten NaCl ionizes to Na plus and Cl minus. It gives NaCl, that means reversible sign, Na plus Cl minus. What is meaning? When Na plus Cl minus again combine, they give NaCl. Then what happened during electrolysis? During electrolysis, here that means sodium metal is deposited at cathode and chlorine is liberated at anode. When the electrolytic current is passed through molten sodium chloride, the chloride ions are moved towards cathode. Why cathode is positive? That is why chloride is negative. Chloride is one negative ion, and here it is and it moves. Chloride moves towards anode and lose one electron and combine with another electron to form chlorine molecule. Na plus moves towards cathode. That means it is positive, it moves towards this cathode is negative. Similarly, anode is positive. So I think it is clear to you. And when current is passed through the molten sodium chloride, which changes to Na plus and Cl minus, and Cl minus means chloride, Na plus means that is positive ion. Then since chloride is negative ion, and so it moves towards anode which is positive. And here Na, what happened? How it changes to Cl minus? When electron lose one electron and combines with another chlorine atom to form chlorine molecule. That means NaCl, here C, NaCl, here what happens? It produces on molten stage. What happens? It changes to Na plus and Cl minus. Then Na plus, how it is produced? It losing electron. Move towards cathode, lose one electron and combine with another molecule. Now it gives chloride ion. This chloride ion, it is a excess of electron. So what happened? Cl minus lose one electron and it gives chlorine atom. Chlorine atom, another chlorine, it gives chlorine molecule. Clear now? Na plus ion moves towards cathode. Na plus, what will happen? Na plus is positive. So it moves towards cathode, which is negative. Accepts one electron to form sodium atom and obtain at cathode. So it is obtained at cathode. So then we will see the reaction are how at cathode Na plus electron, because it is a positive charge that is less than electron, then that is why one electron is accepted and gives Na. Anode Cl minus lose one electron Cl and Cl plus Cl gives chlorine. Overall reaction what happened? NaCl, that molten stage, in molten stage also it gives 2Na and Cl2, cathode and anode. Similarly, if you see aqueous solution, see this is, before that what is that? Molten NaCl, and now it is aqueous sodium chloride. What is meaning aqueous sodium chloride? Aqueous sodium chloride means after varying. Water is adding. Water means aqueous solution. Sodium chloride when added to water, it gives aqueous solution of sodium chloride. What happens here if electrolysis is passed? If electric current pass, electrolysis taking place, then it gives Na plus aqua. Here, why it is not written here aqua? Because there is no water molecule here. But here it is added to aqueous water. That is why you should write AQ. If you are writing only Na plus, simply Na plus, then it is simply, that means it is electrolyzed, not adding any water, molten stage. If you see Na plus, that means sodium chloride is added to water. That is why you should write aqua. Water dissociates and water is there, then what happened? Water is there which dissociates water. You write liquid. L means liquid. Liquid, otherwise simply water, there is so many conditions, vapor, any solid, anything. That is why you should write in bracket L. Then what happened? The reversible sign, meaning these products when combined again it will give water. That is why H plus aqua and OH minus aqua. So the solution of sodium chloride contains Na plus, H plus, H cation. So there are two chances. One is not chance, that is possible only. And what are the cations produced? In one reaction Na plus, before that I told. And here H plus H cation. Similarly, there are two anions. What are that? Cl minus and OH minus. Here this is one anion, this is one anion. Similarly, here one cation Na plus and other cation H plus. When current is passed through this solution, then what happens? Then what happens when current is passed? Then you will see one is chlorine is liberated anode and hydrogen gas is liberated cathode. This is the practical one. And there is a chance. There is a chance, maybe hydrogen, maybe Na. So what happened here? Why it is only obtaining as hydrogen gas at cathode, chlorine gas at anode, not Na, not OH something? What happened? Then at cathode, Na plus, H plus are competing with each other, because you know Na plus and H plus, two cations are produced. Then what is the very active here and how it is proceeding? Let us see. Na plus aqua, you should write aqua. E minus, it gives Na solid. Where E0, you should know. You should collect, you should see in that list that what is the standard electrode potential of this. And so here it is minus 2.71 voltage. This is the standard electrode potential of this reaction, where Na plus changes to aqueous, changes to Na. So next, see what is the value, minus 2.71. This is very important. If you remember, okay. If not remember, you put the value somewhere, you can collect it easily. H plus also, that is cation. So you should takes one electron, gain in one electron, changes to half H2 gas. And what is the E0? You know, standard electrode potential of standard hydrogen electrode, because it is hydrogen H plus only. So you should write the standard hydrogen electrode of hydrogen. What is the value? That is 0 voltage. Now the reaction with high E0 is referred to first. That means here you will see what is the value here, 0 voltage. Then H plus aqueous takes electron half H2, then H plus aqueous is also produced from water. So here as water liquid takes electron, it gives half H2 gas and OH minus. At anode water you are getting Cl minus, OH minus are competing with each other. So here what happens? Here you can see this is chlorine liberated anode and hydrogen gas liberated cathode. Now hydrogen gas how liberated I have explained here. You can see produced from H plus, and here the reaction with high E0 is referred to first. And now that is minus 2 value, minus 2.71. What that one? Na plus electron, where standard electron potential is in minus. Whereas hydrogen, that is 0. So 0 is greater than minus 2 point. That is why the reaction, you should remember this line, reaction with high E0 is referred first. That is why here you will getting hydrogen. And water liquid plus E minus, one side half H2, other is OH minus aqueous. Now here also at anode, Cl minus and OH minus are competing with each other, because you can see the Cl minus also produce, OH minus also produce. Cl minus aqueous, it gives half Cl2 plus E minus. This one already you know. Then here what happened? You should know E0. E0 equal to 1.36 voltage. Similarly, 2 water liquid gives O2 gas and 4H plus 4 electron. Then here, what is the value? What is the standard electron potential of this reaction? This reaction, that is E0 equal to 1.23 voltage. Here loss, that E0 potential, that is 1.23, which is lower. 1.23 is the lower. So it should take place. It is referred first. It should be. What happened then? It should be referred this reaction where it is less standard electrode potential. The reaction at anode with water, that is preferred first. But water should oxidize. Then what happens if it is lower potential is preferred first? Then here water should oxidize in reference to Cl minus. But what happened? Due to over potential of oxygen, then what happened? It is not possible, just reverse. That means reaction of Cl minus to Cl is referred. Then here what are the net reactions? NaCl aqua, the reaction is Na plus aqua, Cl minus aqua. Then what happened at cathode? Cathode, that is water liquid, that is plus electron, then it gives half H2 gas and plus OH minus. That means hydrogen gas is liberated at cathode. Then what happened at anode? Though here lower potential at anode refer first, but here the anode Cl minus aqua gives half Cl2 plus E, because due to over potential of oxygen, the reaction taking place as Cl minus to Cl. So NaCl aqua plus water also you are putting there, that also reaction there, the reaction takes place. So Na plus aqua, OH minus aqua. Then what are the gases liberated at cathode anode? Half H2 and half chlorine. Half chlorine at anode and half H2 as at cathode. The next point, electrolysis of water. Electrolysis of water, how takes place? Actually, we know pure water is a poor conductor of electricity. So here what to do? You will add a few drops of acid or alkali to add, then it may good conductor. A few drops or only sulfuric acid is added to water is a good result. On passing electric current, it dissociates as H plus aqua plus OH minus aqua anode. So at cathode H plus, at anode OH minus, and here reversible sign, when H plus and OH minus combine, then it gives water liquid. This is at cathode and this is at anode. So after that we will see what happens at cathode and anode for the reaction, that is H plus cation OH minus anion. After adding few drops of dilute sulfuric acid, here what is your indirectly you are adding sulfate ion aqueous. And what are they? OH minus aqua. That means these two ions are moved towards anode. Because this is also minus, this is also minus. So it moves towards anode. But which will move faster? Which is the correct one? The sulfate ion aqua will not release since the discharge potential is more as compared to H minus. This cannot be released. This cannot be breaking gives a particular product at anode. Then here why? The discharge potential is more as compared to OH. So discharge potential is high, so it is not possible. Then what happened then? At cathode, the H plus 2 electron gain 2 electron, that is reduction takes place, it gives 2H plus or H2. Because it is gaining electron, Similarly, at anode, OH minus aqua oxidation takes place because it loses electron. OH minus loses electron, it gives OH radical. Before OH it combines, it gives 2 water molecule and oxygen molecule. That means when here due to sulfate minus aqua where discharge potential is more, so that is not possible. At cathode only it gives here OH radical. OH when 4 OH radical combine, it gives 2 water plus oxygen. So electrolysis of copper using copper electrolyte. Before that what you have said? Acid sulfur, that means water. That means you are adding 2 drops or 3 drops of dilute sulfuric acid. When there is no acid, and here electrolysis copper sulfate using copper as electrode. So when you are using copper as electrode, in electrolysis of both copper sulfate and water ionized. Because copper sulfate is there, water is there, both are ionic compound. So CuSO4 gives Cu plus 2 and SO4 minus 2, and water also gives H plus OH minus. That means Cu plus 2 and H plus moves towards cathode. Similarly, SO4 and minus 2 and OH minus 1 both are moving towards anode. But what happened correctly? When Cu plus 2 and H plus ion moves towards cathode, but the reaction with higher, you know, so before that I told, reaction with higher electrode potential, standard electrode potential is preferred at cathode. So Cu plus 2 aqueous plus 2 electron gives copper solid, where this value you should remember or you can collect from the any list. So E0 equal to plus 0.34 voltage standard electrode potential, that is plus 0.34 voltage. And when hydrogen H plus aqua gaining electron, it gives what? Half H2 and gas. And what is the value? Standard electrode potential of SHE, standard hydrogen electrode, that is 0. Then which is a lower value, which is higher value? The copper having higher value, hydrogen having lower value. And you know also at cathode what the higher E0 standard electrode potential is preferred. So tell me, we should be preferred the copper. This one. This is the reaction where we can differ. So the cathode, then what is the reaction? Cu plus 2 aqua plus 2 electron, it gives CuS, solid, depositor. Then here it is depositor at cathode. Which one? Copper. Then come to at anode, what happens? Itself copper undergoes loss of electron. Copper, when loss of electron takes place to form Cu plus 2 ion, which goes into solution. So CuS and plus minus 2 electron, it gives Cu plus 2 aqua. At last copper is deposited at cathode and equivalent mass, equivalent amount of copper from the anode dissolved in solution as Cu+2 ion. Because it is very important, from the Faraday law of electrolysis, second Faraday, where copper is deposited cathode, equivalent amount of from the anode, equivalent amount of copper from the anode. Anode means that is copper dissolved in solution as Cu+2 ion. Then here electrolysis of copper sulfate in water completed. Then what are you using? Platinum electrode. Platinum electrode is inert electrode. Then what happened here? Only CuSO4 in water, nothing else. Because platinum is that electrode is a inert electrode. It has no value inside the reaction, though it can only exchange the number of electrons as electron gaining or electron losing, anything. But copper sulfate in water, then what is the reaction? Copper sulfate in water, aqueous means in water, Cu+2 aqua, SO4 minus 2 aqua. And here that means CuSO4 gives, aqueous solution gives Cu+2 aqua, and reversible sign means here when Cu+2 aqua, SO4 minus 2 aqua come to each other, and here this is the product again. Reversible sign, reversible reaction. And so you can observe this is Cu+2 which will go to cathode, and SO4 minus 2 which will go to anode. Water liquid when ionized, it gives that means hydrogen aqua, H plus aqua, OH minus aqua. Here also this H plus aqua will go to cathode, OH minus will go to anode. SO4 minus 2 will go to anode, OH minus will go to anode. Then what happened? During electrolysis, copper is deposited at cathode and oxygen is liberated at anode. Then why? Why? There are two cations, two anions are produced. You also know that which has higher oxidation potential, that is preferred anode. This is at anode, and lower that is preferred as this Cu+2 H plus that is will go to cathode, not anode. So you should know this is cathode. So you will see here, you should write cathode, and it both will that to move towards anode. Then what happened here? During electric, copper deposited at cathode and oxygen is liberated at anode. Then why? Because cathode Cu+2 that means gains 2 electrons, changes to copper solid, and SO4 minus 2 that means here according to standard electrode potential it has higher value, so copper that is comes to cathode. SO4 minus, OH minus both will move towards anode, but the reaction at anode, this is very important. I have repeated this line again and again. With lower value is preferred first, and at cathode higher value preferred first. At anode lower value of G0 preferred first. So water get oxidized and SO4 minus 2 goes to solution. So water that having reaction SO4 minus 2 that goes to solution. At anode 2 water gives 4H plus and O2 plus 4E means oxygen is liberated at anode. Net reaction what happened? 2 Cu+2 aqueous plus 2 water molecule, it gives 2 CuS plus 4H plus O2. That means here it is liberated at solid deposited at cathode, and here the oxygen is liberated at anode. This is the last product, last line, last sentence, last reaction process, that is cathode, copper deposited, anode, and oxygen gas liberated. When it is gas liberated, what you will use? When it is solid, the deposited word you will use. I hope it is clear to you, and this is only product of electrolysis, and this very big one. So that is why this is regarded as a 16 part 16A, and now next is part is 16B, where I will explain the other parts of hydrolysis, how many reactions are left, that I will again explain. So myself, B.L.Dash, EXPGT Chemistry Kendra Vidya Sangathan. I hope you will subscribe my channel and also share to any person who require this chapter.